Good morning students. Welcome to the 6th lecture of Probability and Statistics Get DA series. In this lecture, we will learn about independent event. So what is independent event? Suppose we have two events, event A and event B. So if conditional probability of event A given that event B has already happened is equal to probability of A, and if probability of A intersection B is equal to probability of A into probability of B, then event A and event B are independent of each other. Let's understand independent event by solving some questions. So here the question is, box contains 4 dairy milk and 2 Kit Kat. So here sample space is equal to 4 dairy milk and 2 Kit Kat. Mod of sample space is equal to 6. So Raj has taken 2 chocolates and put them back. That means sample space is always 6. So what is the probability of first pickup is dairy milk then Kit Kat, first pickup is Kit Kat then dairy milk, getting both dairy milk. Okay. So the first question is first pickup is dairy milk and then Kit Kat. So how many dairy milks are there in sample space? 4. So E1 is equal to dairy milk. So mod of E1 is equal to 4. E2 is equal to Kit Kat. Mod of E2 is equal to how many Kit Kats are there? 2. Probability of E1 is equal to 4 by 6 or 2 by 3. And probability of E2, that is 2 Kit Kat, that means 2 by 6. Why 2 by 6? Why not 2 by 5? Because after choosing, Raj has already put them back into the box. So here it is 1 by 3. So the question is first pickup is dairy milk and second is Kit Kat. So probability of E1 into probability of E2, that is equal to 2 by 3 into 1 by 3 is equal to 2 by 9. This is the answer of question 1. The second question is first pickup is Kit Kat then dairy milk. Here how many Kit Kats are there? 2. 2 by 6 or 1 by 3, and probability of E2 here is dairy milk is the same thing, 4 by 6 or 2 by 3. Here P of E1 into probability of E2 is equal to the same, 2 by 9. So the third question is getting both dairy milk. What will be the answer? Here E1 is equal to dairy milk and E2 is also dairy milk. So the first, how many options of dairy milk? 4. So probability of E1 is equal to 4 by 6. After taking the chocolate, Raj has put them back to the box. So again sample space is 6, and for the probability of E2, the probability is also 4 by 6. So here E1 into E2 is equal to 4 by 6 into 4 by 6 is equal to 16 by 36 or 4 by 9. This is the answer of question number 3. Let's solve another question on independent event. So here the question is, there are 3 chocolate stores. Store 1 has 4 dairy milk and 2 Kit Kat. 4 dairy milk and 2 Kit Kats. Store 2 has 4 dairy milk and 4 Kit Kat left. 4 dairy milk and 4 Kit Kats. And store 3 also has 2 dairy milks and 4 Kit Kats. So you have to buy one item from each store. Okay. Then what is the probability of getting dairy milk, Kit Kat and dairy milk from store 1, store 2 and store 3? Okay. So dairy milk from store 1, Kit Kat from store 2 and dairy milk from store 3. So here sample space is 6, here 8, here sample space is 6. So probability of getting dairy milk from store 1 is 4 by 6. Probability of getting Kit Kat from store 2 is 4 by 8 or 1 by 2. And probability of getting another dairy milk from store 3 is 2 by 6. That is 1 by 3. So what is the probability of getting dairy milk, Kit Kat and dairy milk from store 1, 2, 3? The answer will be 2 by 3 into 1 by 2 into 1 by 3. That will be nothing but 1 by 9. This is the answer of the first question. What is the second question? Second question is 2 dairy milk and 1 Kit Kat. So here from which store is not mentioned. So if we have to choose 2 dairy milks and 1 Kit Kat, the combination will be dairy milk, Kit Kat. This is the option number 1. The option number 2 will be dairy milk, KitKat, Dairy Milk, that is store 1, store 2 and store 3. And the third option is KitKat from store 1, Dairy Milk and Dairy Milk. So in this case, the probability will be from store 1, probability of Dairy Milk will be 4 by 6 into Dairy Milk from store 2 will be 4 by 8 and store 3 will be 4 by 6. In this case, Dairy Milk from store 1 is 4 by 6 and Dairy Milk from store 3 will be 2 by 6. And for this case, KitKat from store 1 will be 2 KitKat, 4 Dairy Milk. So 2 by 6. Dairy Milk from store 2 will be 4 by 8 and Dairy Milk from store 3 will be 2 by 6. So these are my options. So here we will use AND operation and OR operation both. So probability of getting 2 Dairy Milk and 1 KitKat will be 4 by 6 into 4 by 8 into 4 by 6 plus 4 by 6 into 4 by 8 into 2 by 6 plus this portion 2 by 6 into 4 by 8 into 2 by 6. So you can easily calculate this. Here the answer will be 2 by 9 into 1 by 6 into 1 by 12 or 17 by 36. This is the answer of the question 2. So probability of getting 2 Dairy Milk and 1 KitKat. Now we will see some axioms of independent event. So if there are two events, event A and event B. So if A and B are independent, then A complement and B are also independent. A and B complement are also independent. A complement and B complement are also independent. Suppose we have an event A. So if event A is independent of all events, then there is either one of these two cases. Number 1 is probability of A is equal to 0 or number 2 is probability of A is equal to 1. So if probability of an event is independent of all events, then either the probability of that event is 1 or the probability of that event is 0. Axiom 3. So mutually exclusive events with non-zero probabilities are always dependent. What does that mean? Suppose we have two events A and B. If A intersection B is equal to 0, that means A and B are mutually exclusive. We have already learned that. And if probability of A is not equal to 0 and probability of B is also not equal to 0, then we can say A and B are dependent. How? So here is the catch. We all know that if probability of A intersection B or probability of intersection of two events, if this is equal to probability of A into probability of B, then A and B are independent of each other. So here is the catch. If two events are not independent, then they are dependent events. In probability, if two events are not independent, then they are always dependent events. They are dependent events. So why? Because here probability of A intersection B is not equal to probability of A into probability of B. Why? Here probability of A is not equal to 0 and probability of B is also not equal to 0. So but this thing is 0. So how the 0 and non-zero will be equal? That's why they are not equal. That's why this is the axiom 3. This statement states that mutually exclusive events with non-zero probability are always dependent. So I hope you all have understood the axioms of independent event. So now we will learn about independence of three events. So independence of three events. So if we have three events A, B and C, then A, B and C will be independent if these four conditions are satisfied. What are they? So number 1 is probability of A intersection B is equal to probability of A into probability of B. Number 2 is probability of A intersection C is equal to probability of A into probability of C. The third one is probability of B intersection C is equal to probability of B into probability of C. And the fourth and final one is probability of A intersection B intersection C is equal to probability of A into probability of B into probability of C. So if these four conditions are satisfied, then we can say event A, B, C will be independent of each other. I hope you all have understood the concept of independence of three events. So now we will solve few GATE previous year's questions on independent event. GATE CS 2000. Here the question is E1, E2 are two events. E1 and E2. There are two events. So there are three conditions given. Probability of E1 is equal to probability of E2. Second condition is probability of E1 union E2 is equal to 1. And the third one is E1 and E2 are independent. So we all know that from formula of independence of two events, probability of E1 union E2 is equal to probability of E1 into probability of E2. So here we will directly use the second condition, that is probability of E1 union E2 is equal to 1. So what is the formula of probability of E1 union E2? The formula of inclusion exclusion, that is probability of E1 plus probability of E2 minus probability of E1 intersection E2. So we will directly put the value here. Probability of E1 intersection E2 is equal to probability of E1 into probability of E2. So here probability of E1 plus probability of E2 minus probability of E1 into probability of E2. We already know that the first condition is probability of E1 is equal to probability of E2. So let probability of E1 is equal to E2 is equal to X. So from that we can say probability of E1 is equal to X, probability of E2 is also X. So X plus X minus X into X is equal to 1. So that means minus X square plus 2X minus 1 is equal to 0. X square minus 2X plus 1 is equal to 0. This is nothing but X minus 1 whole square is equal to 0, or X minus 1 is equal to 0, or X is equal to 1. So here the answer is D, 1. GATE CS 2003. Here the question is probability of A is equal to 1, this is given, and probability of B is equal to half, this is also given. So we have to find the value of probability of A given that B has already happened, and second is probability of B given that A has already happened. We have to find these two. So how we will find this? So previously we have already learned that probability of any event is equal to 1. That event is independent of every event. A is independent event. So when A is independent, automatically B is also independent of A. That's why A and B are independent of each other. Since A and B are independent, so you can easily use this formula that probability of A given that B has already happened is equal to probability of A. That is nothing but 1. And the second thing is probability of B given that A has already happened is equal to nothing but probability of B itself, that is 1 by 2. Here the answer is 1 and 1 by 2, that is D. So I hope you all have understood the concept of independent event. If there is any doubt, please let me know in the comments. Thank you. I will see you in next lecture.